Thank you, Babis, for this introduction. Hello, everyone. First of all, I would like to thank Yannis Balakakis and I would also like to thank the entire team of the AgriBusiness Forum. I would like to start my presentation by making a brief introduction. Apparently, we are currently going through a period of uncertainty. We have gone through all those things. We had COVID, we have disruption of our food supply chain, then the war emerged, an energy crisis came in, shortages in some foods due to inability of exports, and of course, in all that, one should also consider climate change, which remains a living, an actual risk. And of course, we're being faced with a political system that is unable to make a national comprehensive agricultural policy. I believe that this is a problem. I will try to present you those problems, and I would also like to make some suggestions as to the possible solutions. Let's start with agriculture. We know that's a too complicated system. Tens of parameters affect its operation. Producers need to combine many things in order to grow. I would say that agriculture today is a sort of industrial agriculture with huge inputs and interventions that needs to tackle numerous challenges, and of course it also generates problems to the environment due to the high level of inputs. I believe that today agriculture is under pressure because the reduction in the arable land that is available. I'm afraid that over the past 70 years our state has adopted no measure whatsoever in order to address this risk. I don't know what will happen in the future. We know that the European Commission is exerting pressure, it's putting pressure on the member states to move towards this direction, but anyway. On the other hand, we have been faced with technical problems due to the technical projects that further reduce our land. We also have the photovoltaic parks that are installed in fertile arable land rather than being installed on rocky, infertile land. And another problem for Greek agriculture is the fact that the soil is no longer as healthy as it was. And let's face it, soil is the basis, the foundation of production. Now the problem has to do with the overpopulation on the earth. Yesterday I was listening to the news that we have 8 billion people. We expect this number to further rise, so you do realize that this requires high production rates. And apparently the impact of climate change is always on the agenda. So, is climate change here? Well, I have to admit that 10, 15 years ago, everyone believed that this was part of the far future. I'm going to talk about Thessaly. Over the past 2 years, we have been faced with very bizarre phenomena. It all started out with Ionos, with extremely heavy rainfall. Then we had floods at Thessaly and Karditsa. The government takes pride on the fact that they paid €400 million in compensation for those damages, but I would like to say that half of that money would have been enough to do the water reservoirs at any pass, and if that had been the case, then we wouldn't have seen those extensive floods in the areas. So you do realize that this is a critical problem. In 2021, we had 10 days of extreme heat wave that had a severe impact on our crops. There was also a problem with temperature fluctuations, and we say that today we might have 23 degrees, and the next day we might have 36 degrees Celsius. So you do realize how detrimental that was for the crops. And of course, we also have strong winds, some days of heat wave in early May. And all those things are phenomena that have arrived and have a severe impact. You do realize that now agriculture is being faced with an actual climate crisis. And our situation is rather peculiar because, on the one side, agriculture will suffer the consequences of climate change, and on the other hand, agriculture can also contribute to reducing greenhouse gases emissions. You can see the pie chart here. You see the percentage of greenhouse gas emissions that are due to agriculture. And on the other hand, agriculture can help to carbon sequestration and removal from the air. So you could realize that this is an inextricable part of this chain. In order for agriculture to adapt to those conditions, we need to develop a climate-resilient agriculture, an agriculture that will make rational use of water, soil, land, wind, all the natural resources. And of course, we want an agriculture that will be able to produce as much as we need. According to a UN survey, by 2050, agriculture yield need to increase by 70%. And of course, this requires concerted effort. It is obvious that we need to properly manage and handle natural resources. Let's start with energy. Let's look on the pie chart on the right. In Eastern Thessaly, we have approximately 75% of energy consumed for irrigation. Why is that? Because we extract water from 70 meters deep in order to water our land. We need to reduce energy consumption required for water drilling. Also, we need to reduce the fossil fuel that's currently consumed. We need to reduce the use of fertilizers as much as this is feasible. We need to reduce fertilizers in general and pesticides. We need to reduce the machines and the equipment that we need, because all the tractors you see moving around need huge energy, have huge energy needs. And when you do the multiplication with the hectares that they have to cover, you realize how extensive the energy needs are. Another part, the soil. We need to come up with ways to improve soil health. Today in the European Union, 70% of lands is unhealthy. Therefore, we need to increase the organic content, the density and the biodiversity of the soil. We need to improve the consistency and composition of the soil, relieve its pressure in order to preserve this valuable resource. Third element, water. Water has 4 properties, which also mean that there are also 4 risks. Safety against flood, drought. That was a narrow escape for Greece, but I don't know what will happen next year. We also need water to drink, water to irrigate our crops. And let's say, and you know that some types of crops have higher needs in water than others, so it depends on the arable land and the type of land used. And of course, water can also provide cheap and clean energy, creating the water reservoirs in the mountain. Greece is a country full of mountains, so every mountain could have a reservoir that could generate power, that could also be the safety reserve in case of drought, etc. Now, which are the ideas that have been put forward on the table? We have precision medicine or the regenerative agriculture. We also have 3 pillars. We have rotation of crops, continuous coverage with plant protection and plant residues, and of course reduction or elimination of soil tillage. Those are the 3 elements that we can use, and those 3 things can yield tangible and multiple benefits. First of all, we reduce consumption of fuel, and that's an immediate benefit. To sow, we need €4, and in order to prepare the soil, we need to spend another €5 to €6, where we can have rotation crops and thus further reduce our energy consumption. We need fewer machines, less strong tractors, and those things can help us meet the goal of saving on energy and resources. crop rotation, if we have specific type of crops, we will be able to reduce that. In the case of fodder legumes, and we also need to increase the organic content of our land, something that can help us prevent soil erosion, meaning losing phosphorus and other nitrogen elements that we need in order to ensure that soil is fertile. It will improve the water permeability, the water retention capacity of the soil, and all those things mean that we save on water. It is apparent that in the case of water, we need to come up with ways to save those resources. We need reservoirs, we know that. If we don't do that, well, I'm afraid that we will not have the water that is required to irrigate our crops in summer. But this is not enough. We also need water transfer system around the plain. We need water distribution systems in our fields. And then we need to raise awareness among the farmers so that they can use highly effective irrigation systems and water as much as is needed. Irrigation for the time being is based on the experience of the farmer. If we see that the plant leaves are black, okay, they understand that they have watered it too much. But what happens in the case of the roots of the plants? Because this water that is drained also carries along the nutrients, nitrogen, phosphorus, and we also pollute underground waters. And then we try to explain why we have such an extensive underground water pollution. Agriculture digitization, I believe that there are more competent speakers than myself to talk about that. I don't want to elaborate on it right now. We have sensors in place that allow us to measure a series of things. Also, with soil sensors or drones, things that allow us to collect data about the quality of the soil. On the left side, you can see a tractor that has an integrated sensor that can detect the call of the plant in order to determine how much fertilizer they should administer. This was created by a Greek startup. It's been exported all around the world. In the middle, we have the possibility of opting for drip irrigation and separating the land in zones. That's in a vineyard, in Magnesia. And then we also have other sensors that are installed in water fountains, either from desalination, rainwater wells, organic cleaning wells, and this means that they can create the right mix of water in order to irrigate the land through drip irrigation. Well, over the past years, those things have been tested through the relevant projects. We have tested various aspects that have to do with wheat, and thanks to software that can improve decision-making among the farmers, our yield has improved. We have decreased the production cost by 30%. We offered tangible profit to producers because we were able to sell their wheat at a higher price. We reduced the carbon footprint by 15%, water footprint by 6%, and the ecological footprint by 2 to 8%. And we also achieved the production of products that are suitable for the pasta-making industries. So, agriculture can also use residues in order to generate power through the biomass. It can also increase the retention of carbon in the soil, and meaning that this can absorb carbon dioxide from the air. Here you can see the 4 pour 1000 French term, that this is in France, that they had proposed to increase by 0.04% the organic content of the soil, something that would enable better carbon dioxide sequestration. And of course, we know that the use of mechanic fermentation can also be helpful in terms of energy production, because we can also include elements that enable us to recycle as much as possible in order to reduce the inputs requirement. Now, the conclusions. We see that we do have the practices practices that are beneficial can be implemented in order to reduce energy consumption and also remove carbon dioxide from the air. But how can we do that? Okay, we might expect from dear God to enlighten farmers so that they're doing it on their own initiative. The second possibility is to start implementing what we have just discussed. Mr. Klonaris talked about the fact that we do have the agricultural applications. Mr. Giannakakis talked about the lack of education. We don't have a lifelong training program for farmers. We don't have a system that makes it compulsory for farmers to undergo training or education. We're missing all those things. And this generates bad problems. Another issue, we have the Common Agricultural Policy that provides for a series of policies which are European policies. I don't believe that such a policy can make the decision for us about whether we're going to irrigate 30%, 40% or 50% of the land. It's not the CAP's job to decide whether we are going to consume polished tomatoes in summertime rather than producing Greek tomatoes. This is up to the national agricultural policy to be determined. Since 1980, when we joined the European Union, we made a decision to increase subsidies and aids, and that's all we care about. Couple payments, couple aids, okay, the maize is going to receive subsidy, okay, we will grow more maize, but what are we going to do? Are we going to reduce the crops of alfalfa or any other sort of spinach? What should we reduce in order to replace it with maize? So, where are we going with this policy? What the ultimate result will be? I believe that alongside CAP that offers the right resources to boost people's income, we also need to establish our own national policy that will aim at developing a highly productive, high-yield agriculture that will meet our needs. Thank you.